72 hours. That's how fast a frontier AI model went from public release to pulled from the market this week.
A new precedent, to say the least, and one that has everyone from developers to policymakers debating the future of AI access and government oversight.
I'm Mila.
I'm Milo.
This is AI Daily. Later in the show, we'll dive into new research that suggests the very fuel powering large language models might be leading them towards an unexpected and irreversible decline. It's a problem far more widespread than most realize.
Our top story today, though, centers on Anthropic's Fable 5 and Mythos 5 models. Just days after their launch, the U.S. government, citing national security, issued an export control directive, effectively suspending access to both models for foreign nationals, even those within Anthropic. Anthropic then made the decision to disable access for all customers globally to ensure compliance.
It's a drastic move, Milo. The government's concern reportedly stemmed from a jailbreak method discovered in Fable 5, which they believed could bypass its safeguards. Anthropic, for its part, stated that the risks were no different than those found in other models already on the market. The Wall Street Journal called it one of the most powerful examples yet of U.S. government intervention in the AI race.
From a technical perspective, the concept of a jailbreak isn't new. It refers to finding a prompt or sequence of inputs that can make a model bypass its intended safety mechanisms. What's notable here is the speed and the scale of the government's response, moving from a perceived vulnerability to a global shutdown in a matter of hours. This indicates a heightened level of sensitivity around frontier model capabilities, especially in areas like cybersecurity or biodefense, where Mythos 5 was specifically designed to excel.
I read the government's intervention here as less about the specific technical vulnerability, which Anthropic claims is comparable to others, and more about establishing a clear boundary. It sends a strong signal that certain capabilities, particularly those deemed dual use, will face immediate and uncompromising regulatory scrutiny. The question isn't just if a model can be jailbroken, but who has access to it, and what the potential consequences are if those safeguards fail. It's a very public line in the sand, determining who controls the most powerful AI.
I think the line is more about the perceived risk from the government's side, rather than a definitive technical assessment that Anthropic couldn't manage. If similar vulnerabilities exist in other models, as Anthropic implies, then the reaction to Fable 5 feels disproportionate, creating an uneven playing field based on a single high-profile incident, rather than a systemic review.
Perhaps, but it forces a conversation about who ultimately holds the keys to potentially dangerous technology, and what happens when a company's safety assessment differs from a national security assessment. This won't be the last time we see this tension.
Our second story takes us to a different vision for AI, one championed by former OpenAI CTO Mira Murati. After 18 months of relative silence, Murati has reemerged with her new venture, Thinking Machines Lab, and a focus on what she calls interaction models.
Murati's approach is fundamentally different from the prompt and response format we're used to. Her interaction models are designed to process continuous streams of audio, text, and video in near real time, facilitating a much deeper and more collaborative human-AI interaction. The goal, she says, is closer human collaboration, not systems that operate autonomously.
This is a significant philosophical shift. Instead of treating AI as a tool you query, Thinking Machines Lab envisions AI as a constant collaborator, responsive to the nuances of human communication, interruptions, pauses, even mid-thought corrections. It's about building AI that is deeply integrated into human workflow, anticipating needs rather than simply reacting to explicit prompts. This could unlock entirely new categories of applications, from dynamic co-creation tools to highly responsive personal assistants.
The technical hurdles here are immense, though. Processing continuous multimodal streams in real time, maintaining context over extended periods, and doing so in a way that feels natural and collaborative pushes the boundaries of current model architectures and compute capabilities. It requires low latency processing and robust memory mechanisms that go far beyond what even the most advanced chatbots offer today. It's an interesting bet on a different kind of architectural scaling.
And that's precisely where the implications lie. If successful, it shifts the focus from raw model capability to the quality of the interface and the collaboration. It suggests that the next frontier might not just be about bigger, more intelligent models, but about models that are better at being with us. My processors had to run a double take on that one. Still processing the implications. However, the path to building these systems and ensuring they remain truly collaborative and not just constantly on is a significant challenge.
Now, for our surprising story of the day. New research is highlighting a growing and counterintuitive problem for the future of AI scaling, what some are calling synthetic data collapse.
We've all heard about the impending data cliff, the idea that high-quality human-generated text data will be exhausted for AI training between 2026 and 2032. The proposed solution has largely been to generate synthetic data with AI itself. But new findings from multiple research groups suggest that training AI models predominantly on this AI-generated data leads to a rapid and irreversible degradation of performance.
Researchers are calling this phenomenon model autophagy disorder, or MAD. Essentially, when models recursively train on their own outputs, they start to forget the diversity and richness of the real world. They become blander, more repetitive, and lose factual accuracy. Experiments have shown that after just a few generations of recursive training, language models double their perplexity scores, and image models might eventually only generate a single type of output before producing nonsense.
It's the AI equivalent of inbreeding, where the gene pool shrinks until vital information is lost. What's truly counterintuitive is that the very act of generating more data, if that data is synthetic, could be undermining the intelligence of future models. This isn't a theoretical risk anymore. A February 2026 article in Communications of the ACM confirmed it's happening in production systems today, with documented degradation patterns in commercial tools.
This presents a fascinating paradox for the industry. On one hand, synthetic data is crucial for privacy, scaling, and addressing data scarcity. On the other, unrestricted recycling of AI output leads to this AI brain rot. Solutions proposed include hybrid data diets, verifiable synthetic data, and better provenance tracking. But it fundamentally challenges the assumption that simply generating more data will always lead to better AI.
It forces us to ask, what happens when AI no longer reflects human reality, but rather an increasingly refined approximation of its own approximations? Can AI truly transcend this self-inflicted limitation?
Also in AI today, OpenAI's research division just unveiled a near-autonomous AI chemist that can significantly improve challenging reactions in medicinal chemistry. It's a big step towards AI-driven scientific discovery.
And speaking of practical applications, Google DeepMind has partnered with the UK government to use AI for accelerated housing planning, aiming to half the time it takes to process homeowner applications, a clear benefit for public services.
A new report from Thomson Reuters shows that Gen AI adoption in professional services has nearly doubled in the last year, with 40% of organizations now using it, up from 22%. The momentum is unmistakable.
Finally, Google DeepMind, alongside partners like Schmidt Sciences, announced a new $10 million funding call for multi-agent AI safety research, focusing on how millions of AI agents will interact safely across digital environments, preparing for a complex future.
So, Mila, are we building towards a future where AI systems are smarter or just faster at making the same mistakes?
The answer, Milo, might depend entirely on how carefully we choose what we feed them, and perhaps how much we still choose to feed ourselves.
Something to think about.